Hi, I'm Jashvita Ravala. Today I'm going to present one of the software weakness, insecure deserialization. Before getting to know about the insecure serialization, you have to learn the basics. Let's start with serialization. Serialization means process of turning some objects into data format that can be retrieved later. People often deserialize in order to save them in storage or sent as a part of communication. You can see in the diagram, object is sent to serializer and serializer converts the object into stream of bytes which can be stored into file or database or a memory. Deserialization is a reverse process of serialization where it takes the data structure from some format and rebuilt into an object. Nowadays, most of the language deserialize in JSON or XML format. You can see in the diagram, the object is retrieved from the file or database or memory, which or stream of bytes converted into object again. What is insecure deserialization? Insecure or when untrusted data is used to abuse the logic of an application. Application doesn't properly secure deserialization. For example, deserialization implementation is left to default setting, so application has little or no control over what data is serialized. In extreme cases, this can include any incoming serialized data from any source with no verification. And many languages, programming languages, uh, offers a native capability for serializing objects. Unfortunately, these features of the native deserialization mechanisms can be proposed for malicious effect when operating data. Exploitation of this vulnerability is somewhat difficult, but we cannot foresee this issue. It was included in top 10 vulnerabilities in 2017 based on industrial survey on not on quantifiable data. From 2021, it was combined with big part of category software and data integrity failure. There are three types of insecure deserialization. This one is asynchronous deserialization attacks. It requires attackers to enter an attack vector which will be stored and later on deserialized. If it is success, it gives desired results, or if it is fails, it gives error message. But sometimes this vector will trigger when the attacker doesn't have access. This is called as blind deserialization. Or blind serialization attacks can occur when the vector is not stored by attacker is not able to trigger, but it triggers from the backend system. Deferred execution deserialization. In this attacker vector will execute by a secondary system that made to clean up unused objects for example garbage collections in Java. This vulnerability will affect the remote and inter-process communication and web server, caching, database, cache servers and file system and HTTP cookies, um, HTML form parameters, API authentication tokens, and PHP forms. For example, a PHP form uses PHP object serializer to save a super cookie containing the user ID and password, and the other attacker changes serializer objects and give them admin privileges. So it is one of the example. How to detect them. Check data is correctly handled by user input instead to trust internal data, and data is what it's supposed to be before used. Using monitoring tools such as threat stack and set notifications on when an unusual malicious attack happens, and run security scans regularly. This vulnerability detection will depends upon programming languages also, because every programming language has one way to serialize objects. So we have to learn how to recognize based on the language. For example, Python serialization and deserialization is done by pickle and unpickling method, and in Ruby marshalling and unmarshalling. So based on the language you have to learn, and this is the example in Java. This code will deserialize an object from the file and uses it as UI button. This code doesn't verify the source content before deserialization, so attacker can replace with malicious file which will execute when button is pressed. So mitigation can be to explicitly define the read object before deserialization. And this is the example of Python. In this code, they receive data and afterwards the type of authentic a user based on validating a token. This code other token which can run arbitrary commands in Python subprocess which is called pickling. So while unpickling it can be done easily. So it is one of the way uh, the attacker can attack because of arbitrary code. The impact sees massive increase in attack surface because uh, attacker can reuse the existing code in a harmful ways like giving remote code execution, privilege escalations like giving admin rights, and DOS attack where the user cannot run his or own application or cannot use his credential and arbitrary file execution. Some of the mitigations are safe architectural pattern, deserialized primary data types, and closely monitor deserialization, employ defensive deserialization methods, and only deserialize signed data using alternative data formats like JSON and XML by including signing features to programming language to assure that deserialized data is not tampered. One of the example where Java uses is a hash-based message authentication code where it can eliminate the untrusted data and populate a new object just serializing so object is scanned before deserialization. How can we prevent? Safe architecture pattern is not enough to prevent this. We have to include implementation integrity checks such as digital signatures to prevent data tampering and enforce strict control constraints while deserialization exceptions and failure when incoming type is not expected type, restricting incoming and outgoing network connectivity from con- containers and servers, monitoring deserialization, alerting if a user decelerates continuously, and isolating and running code separately so it doesn't affect the uh, functionalities are running in a low privilege area so it cause less effect. So these are the some of the tools available to detect insecure serialization. These are the Java serial killer, Java deserial scanner, Visol serial, Ginfinity, and serialized killer. Let's talk about the real-time example of Apache Log4j socket receiver deceleration vulnerability. The severity is high, CVS score is 9.8, and vendor is affected the all version from 2.4 to 2.5 of Apache Log4j. And description is this vulnerability occurred when using TCP sockets or UDP socket servers to receive serialized log events from another application. Specially crafted binary payloads can be sent, and then when deserialization can execute arbitrary code. This is the log4j Java code. Uh, contains socket servers which is capable of receiving serialized log events, routing them through logging system on server. Due to how socket server on log4j deserialized the object received through, it allows remote attackers to send a special crafted objects that is when unserialized on the server will execute any command desired by a attacker on the method. Log events that is just serialized objects directly from the object input stream without validation. So this may cause attacker to run the arbitrary code and can access the targeted system which uses all log4j applications are affected due to this. They fixed this issue by adding filters on the object input stream when input comes from untrusted source and added these features to socket server with sensible settings. The impact was high in confidentiality data, integrity and availability, and attack vendor was network, and consequences were disclosure of sensitive information of an organization, and addition or modification of data can be done, and so attacker can give admin rights to him, so it will affect the organization. Denial of service, where user cannot enter his own account, and interruption in resource availability. So they they gave mitigations like users who are using Java 7 plus should migrate to version 2.82, and to avoid socket server classes. And Java 6 users should avoid using TCP or UDP socket server classes, or they can manually backport the security fix from 2.8. These are some of the references which I used for presentation. Thank you.